It's easy to think a main control system is secure in a brownfield or greenfield facility. After all, with all the design requirements and connections coming into the DCS, vendors have that all figured out way ahead of time. But what about the package systems or skids that connect to the main system? How secure are they? My take is these systems often end up purchased from the lowest bidder. And when that happens, you have to ask if security is even mentioned at all in the purchasing requirements. With that in mind, it seems these package systems would be a very dangerous link to the overall cybersecurity at the facility. Hello, everyone. This is Greg Hale, and welcome to another Today with ISS Source podcast. And we're going to explore the idea of how secure are package systems with Eric Forner, Chief Technology Officer and co founder of cybersecurity solution provider Armexa. Eric, welcome.
Hey, Greg, great to be here. Looking forward to talking with you.
And as am I. Eric, I got a quick question, and we talked a little bit ago about this topic, and and I've got to say I was unaware of how big a deal this was. So let me start with a basic question. And as I said a few seconds ago, while the main control system, the DCS, is pretty well secured, the weak links seem to be in the package systems. Could you first explain what a package system is all about?
Sure. So, in many industrial environments, especially in process industries, you have a DCS. So, the typical providers out there that do the core process control for that environment. But in any one of these environments, there's a lot of systems out there that are not controlled by the DCS, and those are called package systems. So what they are systems where an engineering, procurement, and construction company, an EPC company, purchases a capability, and that capability could be an instrument air skid, or it could be another piece of the process that a company builds the physical equipment and then the control system to run it and delivers it to the facility. What happens then is that package system, whatever it is then integrated into the larger DCS so everything can be controlled together. But the reality is from a package system standpoint, that control system is designed and configured by that package system vendor.
Okay, and why are these package systems not as secure as the main control system?
Yeah, and that could be a bit of a loaded question, but the reality is that from a DCS standpoint, that is typically that DCS vendor. That's really their core capability. They're typically very large international companies just because of the capital required to develop those things. And from a cybersecurity standpoint, they're usually just more mature. Um, from a package system standpoint, these are typically smaller companies, very specialized companies, and companies that really their core competency is in the process that they are providing. So if they're providing a pumping skid, or again, like an instrument air skid, their core competency is not control systems. It is the the physical process that they're providing. The control system is merely a means to an end to get that process running. And so what that typically means is that the control system that is running that package skid is either it's either done in house by somebody who may or may not have a lot of cybersecurity expertise, or it's farmed out to a system integrator who may not have any cybersecurity expertise. And really the main reason for that is that these package system vendors are looking to cut down costs, because when they're bidding for a greenfield project, one of the highest levels of criteria for winning that bid is cost. And if those cybersecurity requirements are not baked in to the requirements, they won't be there, simply.
Okay, so going back to what I said in the beginning, also that my understanding is these package systems end up purchased from the lowest bidder.
Mhm.
Is security even mentioned in this purchasing requirement?
It it really it depends on the asset owner, and sort of how mature their procurement language is. For some of the super major oil and gas companies, sometimes it is in there, but for many other companies, it's not. And even if it is, there's a lot of um, layers of indirection, but between the asset owner to the package vendor. So there's the asset owner, which has a contract with an EPC, which has a contract with a MAC, which is a main automation contractor, which has a contract with the package system vendor. So
Mhm.
even if that asset owner has cybersecurity language in there, that may not trickle all the way down to that package system vendor. So that sort of whisper down the alley can lead to a lot of misalignment from a cybersecurity standpoint as well.
Mhm. Now, I'm assuming these package systems are usually not coming in from the DCS vendor as you discussed. So it's what would there be when they are brought in, would there be compatibility issues in terms of cybersecurity and or would that not be much of a problem at all?
There certainly can be. So typically, these package systems uh, communicate with the DCS via third-party interfaces. So from a protocol standpoint, it's your typical Modbus TCP or Ethernet IP or even sometimes serial. So those are typically well defined, and what those Modbus coils and registers are. However, there are, especially these days, like there's Modbus over TLS. So there's Ethernet IP, which can use certificates. So what starts to happen then is if these secure protocols start to be implemented in package system vendors, there can be certificate or other security compatibility issues with the communication between the DCS and the package system, which all leads to increased cost. It can lead to increased cost to the package system vendor because they have to add a capability that they didn't expect. There can be additional cost to the EPC or the system integrator because there's additional work to make this all happen. So absolutely, if the requirements aren't defined up front and that level of effort figured out up front,
Mhm.
it can cause issues during FAT and SAT.
Alright. Now we're always hearing about, the security experts wanting to have security built in, by design, and, but this also sounds like it's more of like a bolt-on approach. I mean, doesn't this fly in the face of secure by design?
Uh, it can. The reality is that it's sort of a difficult problem to solve. The good news is that it's solvable. But from a secure by design standpoint, that typically is much more adhered to by the DCS vendors. They have cybersecurity programs. They follow IEC 62443 standards. The package system vendors, again, because it's a low cost system and because a lot of the changes that you might have to do may apply to one asset owner, but it wouldn't apply to another asset owner.
Mhm,
Typically, what these package systems vendors do is design to the lowest common, easiest to integrate denominator. So the secure by design is not the main objective of them. It is cost and compatibility, which sometimes can be diametrically opposed to secure by design. That is changing slowly, but today it's not a priority for a lot of them.
mhm, mhm. So there's this idea of, poor cybersecurity on package systems, is something that applies to is it something that applies to new builds or greenfield type areas, or is it also, in the brownfield environment and or what is the difference between the 2?
Yeah, so um, the it affects everything. I mean, in new builds, in greenfield projects we are working on today, right now, this is an issue. This is for even builds where we are in the design phase, where this facility won't even be built for 2 years. It's a problem. So, but from a from an integration standpoint, a lot of that is. is, like I mentioned, really well defined. We still use Modbus TCP today to do package
Yeah.
system integration, and that protocol was designed in the 70s, with Modicon. So those sort of communication channels are definitely well defined. They are still relevant, but right now we are just getting to the point now where, hey, just having consistent communication isn't good enough anymore. We need to have better security compatibility between these systems. And it is still an issue today, but I can say that it's much, much better from a greenfield perspective because we've gotten much better in procurement language, number one. And number two is we've gotten much better at the engineering phase to be able to design things properly and collaborate with the package system vendors and the Macs
Mhm.
so that when we get to FAT and SAT, the problems are mostly solved.
Mhm.
So it's good news that it is getting better. It is definitely still a problem.
Alright. What could, we talk about, companies always wanna protect the crown jewels, but, I mean, what could be the end result in an attack on these package systems?
Yeah, yeah, and so great question. So the DCS provides the core process control. So that really is an incredibly important system, and the DCS is usually very tightly integrated. So I think we could all agree on that. However, one example that I would give is an instrument air skid. So almost always, instrument air is a skid that's delivered by Atlas Copco or whoever, and it is plopped down there. And then the instrument air skid has its own PLC on it, and it's integrated using a third party connection into the control system. And that instrument air skid provides air to instruments. And so if that skid goes down for any length of time, it doesn't matter what the DCS commands to valves. There's no air to actually actuate the valve. So those little systems that support the larger control systems are actually critically important, even though they're just a very small part of the overall control scheme, if that makes sense.
Mhm, mhm. Now how can you tell if this package system that you purchased, that you have out there waiting for you, how can you tell if that is lacking security?
Yeah, so and that could be a bit of a challenge. So typically, when you go out there, you just assume that it has no security, specifically from a brownfield standpoint. So you can sort of jump to conclusions pretty simply. And if you can't, that's actually where things get a little bit difficult with package system vendors because a lot of times the code that is being used to run that package system, like the code in the PLC, the ladder logic, is locked down because those vendors consider that to be intellectual property. And so being able to go in there, look at the code, to be able to even see what the firmware versions are, and even to be able to update the firmware on that PLC if you had to, for whatever reason, is a big deal. Because there could be compatibility issues with the ladder logic that's on there if you can even see it. Or you may lose your warranty or your service contract with that package system vendor. So a lot of times what we end up doing is treating the package system as kind of the soft core and then build defenses around it,
Mhm,
especially as it interfaces with the control system and the environment around it.
mhm.
Only because a lot of times we just assume that that package system is vulnerable. And so what we do is instead of trying to fix that is we put those sort of moats and defenses around it.
Right. Well, at what point would you conduct a risk assessment on that system? And would you do that, to one of the systems that are coming in or all of them, and that get delivered on the site?
Yeah, so actually a lot of what we do at our Mexa is perform risk assessments on third-party packages, just because we realize, and a lot of asset owners realize, that they do carry a lot of inherent risk that needs to be measured and mitigated. So your question of when, the short answer to that is as early as we can. The reality is that we try to do it during design such that we can design mitigating controls to be able to secure that system based on the risks that we found
Mhm.
by the time that it hits FAT. So that's really the goal of a risk assessment, is to identify the risks. And we don't want to identify the risks after the system's in production. We always want to do it during that design phase if we can, so we can design those remediations early.
All right. And how many risk assessments and at what points, is kind of what you were saying, would you conduct them? I mean, would you conduct them um, early on, like as you say, during the design phase, and then at implementation, or you just do it the one time, or how many would you do?
Totally. Yeah. And to your point, yeah, like a lot of times in the design phase and certainly commissioning phase, there's a lot of things that change. Commissioning is chaos. Anyone who's been as part of the commissioning of a facility knows that it's complete pandemonium. So everything that kind of that you've done during design kind of goes out the door. So that's not to mean that it's not helpful. It's critically helpful. But so that is to say is that the recommendation is that we do a risk assessment with these package system vendors, typically early on in the design phase, which informs our design to do mitigating controls. If we can actually increase the security of the package system, that's great. What we do know during SAT and certainly after handover is things are going to have changed. Things were plugged in that we never designed to be plugged in. Um, there's a lot of different things going on. So what we always recommend is that post SAT, we perform a risk assessment so we have that delta. And so once we understand that delta, that informs our risk posture moving forward. So then we can have those regular risk assessments, let's say on a yearly cadence, so that we can measure it and measure our improvement moving forward.
Mhm.
So during a capital project, I'd say 2 times: during design and post SAT.
Right. So you would, um, after the risk assessment, what are the challenges to securing these systems?
Yeah, definitely the big one is contractual language that drives change orders. And so EPCs are rightfully so extremely focused on budget and cost. And so a risk assessment will invariably find certain risks to package control systems that could require a change order because it was never spec'd in. It happens all the time. So that in and of itself is a risk to project budget and to project schedule. And
Mhm.
so what we try to do is to sort of meet it in the middle, right? So, hey, maybe there's some sort of mitigating control. For instance, maybe we can put this package system on the third party network on its own VLAN. We know exactly what communications need to go between the DCS and that third party skid package. So we put it on its own VLAN. It's behind a third party firewall that can only talk to very specific things, and it's isolated from every other package system. That can be an appropriate mitigating control that's very easy to do during design, very hard to do during uh, once a facility's running. So
Mhm.
it's those sort of things that we try to do up front.
Mhm. Um, how would, in terms of, how, and this may be a silly question, but in terms of segmentation, if you follow the 62443 standard, would you segment these individual systems from the DCS, or is that, or would that not apply?
It totally would. So, and I would argue that the zones and conduits really apply particularly well in package systems,
Yeah.
where in maybe the traditional Purdue model is that, hey, these are all level one, level two systems. And so because they're on the same level, they're on the same network and no problem. I would argue that is not a good way to design a third party infrastructure that has package systems on it. What we typically do, and this changes per project, but just as a go by from a zones and conduit standpoint, is we can group systems that have similar functions into a zone or similar vendors into the same zone. And those zones then have a conduit, which is typically a third party firewall, which then interfaces with the DCS and the rest of the world if it needs to. Typically, it doesn't. But you would have a series of zones that are defined based on some criteria. Again, those two vendor and functionality could be criteria that you use to define your zones. And then another zone would be the interface to the DCS itself.
Hmm.
All of that is going through a firewall is the typical approach. Um, from a the reason why we do it from a vendor standpoint is just if a vendor comes in and plugs into the control system, we want to make sure that that vendor can't affect other vendors' skid packages. So it's maybe less from a cybersecurity standpoint, but more from a finger pointing standpoint is we zone that way.
Okay. And in reality, and as I mentioned in the opening, across the industry, how much of an issue is this? And how dangerous is it?
Yeah, and so a lot of times risk assessments will bring that to bear of just how many risks are there. I would say as a general statement, um, I have never been to a facility of size, right? There's tiny facilities like an RTU along a pipeline, but any facility like a compressor station, a refinery, anything, right? We typically work here with oil and gas companies here in Houston. I have never seen a facility that does not have a skid package, not
Mhm,
once.
mhm,
So either you have a DCS with a variety of skid packages supporting it, which is typical, or you have a lot of PLCs where essentially the control system itself is a series of skid packages that are integrated together into a unified HMI. So that is to say, it's very widespread because package systems are absolutely everywhere in our
mhm.
industry.
Well, Eric, you've given us a lot today, and I appreciate that. But that's about all the time we have right now. So Eric, for Eric Forner and our Mexa, I want to say thanks for listening, and we'll catch you all next time on Today with ISS Source.
Been a pleasure. Thanks so much, Greg.
Thank you.
Resonate.